This is lesson 43 from Algebra I. And this is the second part where we just talked in the last lesson, or at the beginning of the lesson, about finding the least common multiple. And now we're going to find the least common multiples of algebraic expressions. So meaning we're not just using numbers, we're using variables as well. The most common reason for finding the least common multiples of other numbers is to help find a common denominator. So one of the examples they have in your textbook takes the fractions 1/4 plus 5/8 plus 7/12. So this is an example. This is not an algebraic example. This is one just using numbers, but where we would need to look at the 4, the 8, and the 12 to figure out the least common multiple. So if we drew our trees that we just did before, 4 breaks into 2 and 2. 8 breaks into 2 times 4, which breaks into 2 more 2s. And 12 can break into 3 and 4. So if we're looking at this, the least common multiple will be 2 2s and 1 3, it looks like. Or actually 3 2s, because there's 3 2s in the 8. So one more 2 here. So our least common multiple is 3 times 2, which is 6, times 2 is 12, times 2 is 24. So that helps us put each of those fractions over 24. And to make the 4 into 24, it was multiplied by 6, so I'm going to multiply the top by 6. This 8 turned into the 24 by multiplying it by 4, so I'm going to multiply 4 on top. This 12 became 24 by multiplying it by 2, so I multiply 2 on top. And these all result, when you add the numerators together, 25 or 35 over 24. So that was just an example of why we need to find the least common multiple. Now, if we have an algebraic expression, meaning we're going to use some variables as well, we will have, here's an example they're giving us of 2 fractions to add together. So these two do not have the same denominator. Even though we have similar variables, they both involve a's and b's, they're not the same because the a is squared in the first one and not in the second, and the b is cubed in the second one and not in the first. And for our numbers, 15 and 10 aren't the same either. So we want to find the least common multiple of these two. And in order to do that, we're going to do the same thing we did in the last lesson, where we write out the prime factors of the numbers. And also, we want to look at the variables as being their own prime factors. So, for instance, I'm going to take the 15a squared b, and I'm going to write out the prime factors of 15. So if you need to, on the side, create a tree to do that, some of them you can probably do in your head, but not necessarily all. So this one, you already get down to 3 times 5. So these are already prime numbers, these 2 factors of 15. So the 15 breaks into the 3 times the 5. And then we just write our variables out individually in this list. So we have 2 a's because it's a squared, and 1 b because it's not squared. So this is sort of the list that we were doing in the beginning of the lesson of writing out our prime factors, but it also includes the variables. So now we're going to do the 10ab cubed. So if I break my 10 into 2, it will be 2 times 5, and those are both prime, so we're done with our tree. So we'll have a 2 times a 5, and then we're just going to have 1 a, and we're going to have 3 b's. So this is my list of prime factors here. So to find my least common multiple, I'm going to take each thing and make sure it's represented, and I'm going to make sure they're represented to the greatest number of times they're used in each one. So I need to include a 2. So I'm starting with this 2. Then I include a 3. And these both have a 5, and the 5 is only used once in each one. So I only need to include it once here. Then for my A's, there's an A here and 2 up here. So since it's used the most times in the top one, I'm going to make sure to include 2 A's. And then for my B's, I have 1 and 3. So again, the greatest number would be 3. So I will transfer all 3 B's here. So my least common multiple will be 2 times 3 times 5, which is 30. And then it includes 2 A's, so I'll rewrite that as A squared, and 3 B's, so I'll write that as B cubed. So I'm going to double check and look in my book to make sure I did it correctly. So that is the least common multiple of the 2 fractions. So to solve this problem we had above, I'm going to come rewrite it below. So to rewrite the problem we had above, I'm just going to start out by writing our new common denominators for each one. And I'll scroll back up. So we started in the first problem with 15a squared b. So to figure out what we need to transform the new numerator to, we had a b up top. We need to multiply the b times what's left when we figure out how we transformed the 15a squared b to the 30a squared b cubed. So the 15 had to multiply by a 2. And the a squared is still represented, so I don't need to add any additional a's up top. And the b turned into a b cubed, so I added 2 more b's here, and we already had a b, so I'm going to just add that here. So I'm going to make this kind of a multi-step problem. Looking at the other side, scrolling up, oh sorry about all the little extra marks, I'm learning how to scroll on this. So here we started with 10ab cubed. So if we bring that back down and look at how we transformed that, 10 has to multiply by 3 to get the 30. So I'm going to have to multiply by 3 up here. The a gets an additional a to become a squared. And then the b cubed, oh, I apologize, I rewrote this wrong. When I was rewriting this, I accidentally wrote it squared. I'm going to make sure. I was trying to figure out how that happened. So the b cubed is already represented, and I already had a c up top. So I'm going to keep that c here. So now that I have this represented, I'm going to come down below and make this look a little nicer up top and rewrite my 2 as b cubed over 30a squared b cubed. And then I'm going to rewrite this as 3ac. I don't have to have the dots there. And I'll rewrite my denominator again. So now to merge these together, because they have the same common denominator, I can just rewrite that common denominator, and then I rewrite the numerator as 2b cubed plus 3ac. Because that just, it allows us to merge these together up top into now one fraction where they're included together. The book did not work this out fully. I just wanted you to see where this ended up going of why we found the least common multiple of these 2 algebraic expressions. So keep me posted. Let me know if you have further questions or need further example problems.